Okay. So calculations with Ka. Now, given the K value of Ka and initial concentration of Ha. If these two things is given, you can calculate the equilibrium concentrations of all species using ice chart. Remember, we worked on it. Okay. Now let's say second one, if given the value of Ka and the initial concentration of Ha, if these two things is given, then you can also calculate the degree of ionization. And the percent ionization. So you can also, whenever it is given, you can calculate equilibrium concentration of all species. You can calculate degree ionization and percent ionization. And let's see the third scenario. I'm going to write the third one. Given the pH of the final solution and the initial concentration of Ha, you can find the value of Ka and the percent ionization. So let's say if some pH is given of the final solution and initial concentration, then you can calculate. Okay. So those three things you need to consider, and then you can work on it. So let's work on one problem. All right. I'm going to write that problem, and then we will work together. Sore throat medications. Sore throat medication. It sometimes contains phenol, and we can write HC6H5O and a 0.1 molar solution of phenol has a pH 5.43 at 25 degrees Celsius. Now, we need to calculate what is the acid ionization constant Ka of this phenol at 25 degrees Celsius, and we need to find out what is the degree of ionization. Okay, so that two things we need to find. Now, first we need to make ice chart. So let me write at C6H5O H2O, which is in equilibrium, is H3O plus and C6H5O minus 1. Now ice chart, initial we have given 0.1 and these are zeros and zeros. Minus x is a change, in here plus x and plus x, and equilibrium 0.1 minus x, x and x. Now we were told 5.43 pH. If we were told 5.43 pH, we can find H plus ion concentration from it, right? If it is H plus ion concentration, when we calculate, we can plug it in here, in X value here. When you find that, then which is equal to this concentration as well. And then when you plug that value in here, you can get concentration of these species. So when you find H plus ion concentration from pH, you get H plus ion concentration 3.7 times 10 raised to minus 6 molar. That is X. That's the value of X. So here when you plug in 3.7 times 10 raised to minus 6, you can find saying about 0.1 molar, which is very less. So we said this is going to be about 0.1. So now, hold on a second, I'm going to go over and calculate Ka expression for this equation, okay? And then we will find out percent degree of ionization. So hold on just a minute. So when you write Ka expression, we have H3O plus ion concentration, C6H5O minus ion concentration at equilibrium, and at C6H5O. Now remember, we had those concentration given 3.7 times 10 raised to minus 6, and it's square because both are x, and that's what we found, and it's going to be 0.1. When you solve, Ka equals 1.4 times 10 to negative 10. That's the Ka value. So from pH you can find H plus ion concentration and plug those in. Now we will find out degree of ionization and percent ionization. Let me explain those steps as well, and then I will go over with questions that you have. So degree of ionization.
Can you go back real quick?
Degree of ionization, which is x divided by 0.1, and x value is given 3.7 times 10 to minus 6 and 0.1. So you can calculate degree of ionization. 3.7 times 10 raised to minus 5. And when you calculate percent ionization, you can say 3.7 times 10 raised to minus 3%, or because what you do, how do you calculate percent ionization? Degree of ionization, whatever you have, times 100. That's the equation. When you times 100, you get, and you can express into 0.0037. So that's percent ionization. So that's how you can calculate. If pH value is given, you can calculate Ka value, degree of ionization, percent ionization.